Well, in this video, we are going to talk about the second part of vector calculus. So, I have told you what is vector point function and what is scalar point function. Now, we should talk about the vector field and scalar field. What is a vector field and scalar field? In simple language, vector field is a kind of field where we can operate the vector point function. Let's say this is the vector field and this is the vector point function, let's say f, x, y, z, with a vector symbol, and this is the vector field, which is a kind of ground, you can say, right? In that ground we can operate the vector point function, like you can operate in your school ground or college ground or whatever, something like that. As same as scalar point function and scalar point, not point actually, scalar field is a kind of same concept. Here we are applying something like this is the field and this is the scalar point function, let's say f, x, y, z. We can operate the function in that field. Okay, we can operate. In generally I use short forms because my spelling is too much damn, you know what I mean. So let's move on to the next topic called level surface. What is a level surface actually? Level surface is a kind of the highest range. Let's say I'm talking about a kind of ocean waves or sea waves looking like that. It is moving forward, it is moving in the forward direction, right? So this surface I'm talking about, this surface, because this is a 3D wave, not a like 2D wave. This surface is called the level surface, the maximum range of the level surface. You need to know about the level surface. Let's say I am talking about a circle and I am talking about only the perimeter. In that case it is a level line, because I am talking about a line, it is a level line. But when I will talk about this region, which is a kind of disc actually, or ring, not ring actually, it's a kind of plate. In that case it is a level surface. Like in case of sphere we will deal with level surface only without hesitation about level lines, because there is no line, this is only a level surface, a surface. Hopefully you can understand. I can't visualize, um, and I can show, but I can like tell you the concept. Like sphere has not any kind of line, it has only a surface at the outer body. This is the level surface. And why it is known as level, it is known as surface, but why the level term is included here? What is the reason? Because it is the level of the surface. Like maybe the sea wave or ocean wave or whatever is moving in the forward direction or in the backward direction. Not in backward direction, it is not possible, but still just understand it is moving in the forward direction, right? So the level surface is increasing, so basically the level of the surface is increasing, right? This is the level 1, let's say, and this is the level 2. It is increasing, it is increasing. That's why it is known as level surface. Very nice. Now let's talk about another important term called gradient. Maybe my spelling is correct, however. What is gradient? Gradient is a kind of perpendicular vector at a particular point of a level surface. Let's say this is the level surface and I am talking about this point. This point is, let's say, P. In that case the perpendicular vector, point to be noted, perpendicular, let's say I am denoting the vector as G vector. The perpendicular vector is known as the gradient at a particular point, and if you want to find out, you need to talk about this formula. Now what is that? This is phi. Phi is nothing but the level surface, ls, level surface, ls for level surface. And what is that triangle, or like reverse of the triangle or something like that? It is known as del or nabla, nabla operator. Okay. And del is looking like something, that del is a vector. In multiple books you will see this symbol, or in multiple books you will not see this symbol, but actually this is the valid way to justify or to show the nabla or del operator or whatever. So basically it is looking like something, del by del x I cap plus del of del y j cap plus del y del z k cap, right? This is the del, or this is called the nabla operator. Now the phi, point to be noted, phi is a level surface, and let me introduce you with three things. First of all, let's say this is nabla operator, this is a vector quantity. Now three things can possible. First of all, I am talking about let's say f, where f is not a vector, it is a scalar. Scalar what? Scalar point function. In that case we will get a vector. Let's say this is g for gradient, actually g for gradient. Okay, again maybe my spelling is not wrong, hopefully. So however, proceed. Now when we will do multiplication between two vectors, then we have two procedure to multiply. First of all, dot product. I am talking about a vector point function. Now if we do a dot product, then it is known as, let's say, dot product in the set d. Okay, it is known as the divergence. Okay, it is known as the divergence. Very nice. Now we should talk about cross product. Let's say the same vector cross product, let's say we are denoting cross product, the final result of the cross product, as c vector, and the answer is what? C vector, let's say. So it is known as curl. Hopefully it is visible to you, like what is gradient, what is divergence, and what is curl. In this video we will talk about gradient first. So what is gradient? I have told you that what is gradient. Gradient is nothing but a perpendicular vector at a particular point of a level surface. Now it is denoting the maximum rate of change of the level surface. Like in that case, the sea wave is moving in the forward direction, right? And the level is increasing. Gradient will provide us, actually the magnitude of the gradient will provide us the maximum rate of change of the level surface. Because it is increasing or decreasing doesn't matter. Actually, if it is decreasing, then the magnitude will be negative, right, with respect to the increasing perspective. So however, hopefully you can understand what I mean. In that case, gradient, the magnitude of the gradient is giving us the maximum rate of change of the level surface. Maybe it is increasing, maybe it is decreasing, doesn't matter. In case of increasing, it will be positive. In case of decreasing, it will be negative with respect to the perspective of increasing. So however, in that case we have sorry, wait a minute. Okay, fine. In that case we have talked about the gradient. So now let's talk about the use of gradient. I have told you the gradient is nothing but the perpendicular vector. Now use of gradient is something like, let's say, wait a moment, let's say there is a surface and this is another surface, and we want to find out the angle between them at a particular point. Let's say this is P, this is the particular point, and we have to find out the angle between two level surface. These are level surface. Okay, this is, let's say, L dash, and this is, let's say, L. We have to find out the angle between two level surface at a particular point. How we can find out? It's very simple. Let me zoom it down. If we are zooming it, then we will get a kind of straight line and straight line, right? Because the segment is nothing but a straight line. In that case, this is a straight line. And if we are extending the straight line, then this is the angle. So if we are doing something like that and something like that, then this angle is nothing but the angle between these two straight lines. These two straight lines are nothing but the gradients. Okay, this is g dash vector and this is g vector. G dash vector, sorry, I have written it reversely. Sorry, wait a moment. This is g dash vector. Actually, this is the gradient of this surface. Wait a moment. This is the gradient of this surface, right? And this g vector is the gradient of this surface. Hopefully you can understand. So we just need to do a simple dot product between two gradients, which is nothing but the magnitude of first gradient into magnitude of the second gradient into cos what theta. Theta is nothing but the angle between two level surface. This is the use of gradient. So this is all about today's video. In the next video I will try to show you some examples about gradient, and also I will talk about the directional derivative. Now in directional derivative you need to talk about a kind of unit vector, you need to talk about a kind of projection. What is projection actually? You need to play with the direction of the second vector. Actually in directional derivative we need to talk about another vector, which is basically a kind of let's say this is the gradient. We are talking about a perpendicular direction, the maximum rate of change at the perpendicular direction in case of gradient. Now in direction derivative we talk about another vector, or we will talk about the maximum, not maximum actually, rate of change of the level surface at another direction. So this is all about today's video. In the next video we will talk about directional derivative and some examples about you know uh, gradient. So goodbye, thank you.